been built on which ideas? Which has been built on this. If this is true, then what we picture as circular motion in reality actually has this kind of path. Hello guys, welcome back to another video. Now, in this video, I'm going to be showing you why I believe that there is no such thing as a circle. And by circle, I'm referring to something that looks like this. Imagine this is your common circle. I'm saying this does not exist. It only exists in our minds. But in reality, there is no such thing as a circle. And I'll explain why. Let's get into it. Now, if we assume that Newton's first, second, and third law are correct, then we can deduce from this that this is entirely impossible in reality. Now, what does Newton's first law say? Newton's first law says, generally speaking, I'm going to be generalizing this, a body will continue in its state of rest or linear motion unless acted upon by some external force. That is the first law. What does the second law say? The second law says, generally speaking again, the change in momentum of a body is directly proportional to the force applied to it. And the two are in the same direction. And what does the third law say? The third law says, basically speaking, to every action there is an equal and opposite reaction. Now, I'm going to be using this too. I do not know if I'll invoke this third one, but I know for a fact that I'm going to be using this too. Now, what happens is, beginning with this, now remember our aim is to show that in reality, there is no such thing as a circle like this curve you're looking at here. In reality, there is no such thing as a circle. At least I believe. If you believe my proof or my reasoning is incorrect, please let me know. We want to learn as a whole. The whole idea of this video is not for me to tell you guys that you are wrong in any way. Be it your mathematicians, be it your physicists, or be it your just students. The goal in the end in science is for us to all learn. So if you think my reasoning is wrong, please let me know in the comments and let us reason together so that we come to a true understanding of science as a whole. Now, according to Newton's second law, the change in momentum of a body is directly proportional to the force applied. And the two are in the same direction. Now, let's say this over here is a particle. Now, forget the idea that this particle looks circular, like in the edges. Forget that. Let's just imagine that this is a particle. It might be in the form of a square. It might be in the form of a triangle or whatever. Let's just say this is a particle. Now, let's say we apply our force F. Now, the moment we apply our force F at a certain instant in time and remove the force, this particle over here, that is, in the following instance in time, this is no longer available. This particle over here will move with a velocity v, which corresponds to the size of the force applied. So I hope we are agreeing on that point, that once we apply our force F and remove it so that it's only applied at a single instance in time, the object or the particle which experienced the force begins to move with a velocity v, which corresponds to the size of the force applied. Now, according to Newton's first law, this object or particle, this point particle, will continue moving in this way, in this linear way, unless we introduce another force, unless an external force is applied, so as to do what? So as to change its direction, or change its speed, its velocity, or change its motion in general. So unless an external force is applied, this, according to Newton's first law, will continue moving in this way. That is, will continue having a velocity of v in every instance in time. Now, coming to our circle. Now, in physics, we believe that there is something called circular motion. And what we mean by that is an object can trace out a circular path or trajectory in space. That is what we believe. And we believe this building all our principles of circular motion using this as the foundation. Now, using this as the foundation now, to investigate whether for a fact it is true, like for a fact, that objects in reality can perform circular motion, that is, they can trace out circular trajectories or curves, this kind of curves. Using this as the foundation, let's investigate that. Now, say our object is at this point. Assume that circular motion exists, and our object is at this point in the circular trajectory. Now, our object is moving with a velocity of what? With a velocity of v. Now, in order for our object to move from this point and get a velocity, let's call this v1, and get a velocity v2 over here, it has to experience a certain force that changes the velocity from this to this. That is, according to Newton's second law. I haven't introduced anything outside of Newton's second law, I believe. If I did, please let me know. And if whatever I introduced is incorrect, let me know again. Remember, we want to learn together here. So now, in order to change this velocity into this, there has to be a force that has been applied to our object over here. In general, we always assume that our force is directed towards the center. That is, the force causing the circular motion is always directed towards the center. I do not care about those details now. What I care about is this. Let's take this object and put it over here. So our object here has a velocity of v1. And we are agreeing that in order for it to obtain the next velocity in time, it has to experience a what? A force. Now, look at this. This tells us that before the force comes, in this case, we are experiencing linear motion. Linear, not some curved kind of motion, linear motion. This tells us that before we introduce the forces responsible for changing the trajectory of this object from this path to this path, or these paths, as we go. That is, before the velocity changes from this here and turns into this, this applies. Before a force has been introduced, this applies. What exactly is applying in this case? What is applying is that if a force is not introduced in the following instance and time, this will follow this path. But because a force has been introduced, this velocity has changed into something else, into v2. Let's say this point is right next to this point. Let's say this point is right next to this point. It's over here. v2 now, our object is now possessing a velocity of v2. But notice now, v2 is in a different direction. So, what this is telling us is this. Now, I want us to agree here. We do not have anything in physics. We do not have anything called a curved force. That is, we do not have a force like this. Let's call this F1. We do not have anything like this. As far as I know, if you're applying this, we do not have anything like this. We only have this. That is to say, every force applied on a certain object acts in a single direction, Not in this direction, this direction, and then finally in this direction. No, we only have a force that acts in a single direction. Now, this being true, so the second law, when the second law talks about force, it's not referring to this imaginary force which is curved. No, it's referring to this force which is directed in a single direction in an instant in time. Now, if we apply our force on this object now, say we apply our force on this object, knowing that this is in a single direction. Let's rub this now. Or let me put it over here on the side, so that you always bear it in mind. So I'm saying in reality we have this, we do not have this. Let's call it F naught now. Now, looking at this object, say we apply a force of, say, let's call it F1. For a moment, okay, forget this for a moment. Let's just say this is an object moving in space with a velocity of v1. And at a certain instant in time, we apply our force of F1. What happens? The moment we apply our force of F1, we impart a corresponding velocity. Okay, this won't be looking good. So let me say, let's call this F5. Let's call it F5. Because I do not want to use this one over here. Let's call it F5. Say we apply a force of F5 to our object over here. It imparts a corresponding velocity of what? Of V5. So what happens as a result? Let's now imagine this is no longer a force, but this is now the velocity that has been imparted. F5. What happens is, once this happens, using the rules of vector addition, we get a resultant here of, let's call it V arrow, arrow for resultant. So once we apply our force of F5 during a certain instance in time, this force is responsible for imparting the velocity V5. So once the velocity V5 has been applied in that instance, we get a resultant of VR. So this is what we're going to get in the following instance. That is to say, once we apply this force, in the following instance, our object is going to be here. Let's say we're looking at things at the microscopic scale. Let's put VR over here. What is going to happen is our object is going to move from this point. Instead of going in this direction, our object is going to move from this point up to this point. So at this point, it's now moving with a velocity of what? Of VR. This same VR, which was a resultant, is now the velocity it has possessed. Now, say we no longer apply a force when it's at this point. What then happens is that this, according to Newton's first law, will continue moving with the velocity VR unless an external force has been applied on it. So what we then have is a scenario where, like at the microscopic scale, it's a scenario where the object was here and at this velocity, but now the object is here and has this velocity. Again, these diagrams are not drawn to scale. So our object here at a velocity of V1, now it's here, it has a velocity of VR. And what happens is, the moment we decide to again apply another force, let's say we apply another force in which direction? In this direction. This is in another instance in time. And let's call this force omega. F omega. F omega is going to impart a velocity of what? Of V omega. In which direction? In this direction. So we're going to get a velocity of v omega. And what is the resultant? The resultant will be this. So our object will move from this point up to this point. And at this point, it's now moving with what? It's now moving, let's now rub this so that I don't confuse you. It's now moving with a new velocity. Let's call this new velocity Vf. Now I'm going to rub a bit of the diagram so that I do not confuse you. So I'm going to rub this portion over here so that I only leave the arrows, the essential arrows. So we've got something like this. Okay, so we've got something like this. This is V1, this is VR, and this is VF. So this is now the path being traced by our object. But now, I want you to notice that the same principles or the same reasoning we've been using here is the same reasoning that applies to our object here. That is this object. This object. This kind of reasoning is the exact kind of reasoning that applies to this object in order to change its course of movement. So, if you look at this now, we had our object at this point, and we applied a certain force, it went at this point. We applied another force, it went at this point. Now, if we are to trace out the trajectory, that is the path would look more like this. So instead of having something like this, moving from this point up to this point, we have something like this. So what do you think happens in this case? At the microscopic scale. Remember, this reasoning is a complete result of using Newton's laws of motion. Now, if I introduced anything external outside of this, please let me know. So, if this is true, which has been built on which ideas? Which has been built on this. If this is true, then what we picture as circular motion in reality actually has this kind of path. This, 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 this. Okay, wait. This, this, and this. This is what is happening in reality. Not this. Because our eyes cannot see deep enough, what we see is this smooth looking thing, what we call the circle. But in reality, the object is moving from this point. This is happening at a microscopic scale. So we've got a polygon with multiple sides, not this number of sides, like multiple sides. So object is moving from this point to this point. So it's tracing this path. This, 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 and so forth. It's tracing this path and this path and this path. But when I say it's tracing this path and this path and this path and this path, that is, it's turning, it gets here, it turns. When I'm saying it traces those paths, I'm not saying it literally follows those paths. If you watched my earlier videos, please go and watch my first videos. I mentioned that the object doesn't trace this path. That is, it doesn't follow each and every point in this path. But it disappears from this point and appears at this point. And then it disappears from this point and appears at this point. Why is this a necessary thing for objects in reality? That is so that we do not end with Zeno's paradoxes. So it has to disappear from this point and this point. And this avoids the idea of our object having to go through infinite points in a finite line segment. So to counter that, I believe what happens in reality is our object disappears from this point and then appears at this point, and then disappears from this point and then appears at this point. So if we come back to this, our object is not tracing out this path, but it's disappearing from this point, appearing at this point, disappearing from this point, appearing at this point, and so forth and so forth and so forth and so forth and so forth. But when we come, we trace out this as the overall path of the object. So we say the object is following a path that is more like this, and not this. This, like I repeat, this doesn't happen in reality. And the same thing applies for each and every curve you can think of. Even if this were a parabola of a projectile does not follow a curved path. The path it follows, again, is similar to this. It's this, 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 something more like this, not something more like this. Now one may be like, okay, fine. The circle in reality doesn't look like this, but is actually this. But if we separate physics and mathematics, in mathematics we do have a perfect circle, but in reality we don't. But if we go to mathematics and look at how mathematics was built, starting from Euclid's time, Euclid's ideas, if they're his, are built upon the principle of using what? The compass. Now, if you take a compass and you put one tip at this point and you put the end with the pencil at this point and you begin tracing out a circle and you get your nice looking circle on your paper, you might be tempted to think that, well, this is a circle. Yes, in reality, we don't get circles, we get this, but this is a circle. But I want you to put something in mind. The moment you put the tip of your compass at this point and the tip of the pencil at this point, the tip of the pencil is now the same as this object over here. They become the exact same thing, because remember, the tip of the pencil is actually a real thing, a real physical thing. So the moment you begin moving the compass, while you believe you're actually tracing out a perfect smooth curve you call a circle, what you're really tracing out in reality, because still the tip of the pencil is a physical object which you're moving through the application of a force. So what you're really tracing out at the tiniest possible level is still this. So you'll find that in reality, both in physics and mathematics, we do not have anything whatsoever like this, which we call a circle. What we in fact have is this. I don't know what you would term this. It's a polygon, but I don't know what you would term it. This is what we have. We do not have this in reality. Now, let me not be mistaken for trying to drill these ideas into your head. This is my kind of thinking. This is my kind of thinking. I am by no means trying to debunk what others have already established. No, this is my kind of thinking. But I invite all of you guys, I invite all of you in the comment section. Let's talk about this. Let's discuss about motion more in general, and let's discuss more about physics in general. Let's plow deep into this stuff. My goal in the end, guys, my goal in the end is to make sure that everyone who watches these videos, everyone who watches each and every lecture of mine, if I do deliver lectures, everyone who watches my lectures in this particular channel is enabled to follow his or her curiosity and not brush off the curiosity and accept what has already been established. But my goal is to make each and every one of you think better, like plow deep when you're thinking, and not accept each and every facet of truth which has already been established, but to question, so that we see that The physics we are building here is a firm foundation. Because if our foundation is more of feathers, the physics, what follows after, is basically nothing. So we have to establish a really strong ground, a really strong foundation for our physics, for chemistry, for biology, whatever, the science, for engineering, and for math. So my main goal, I repeat, is not to drill these ideas into your head. These ideas might be wrong. Someone out there might be able to dig even deeper and deeper and deeper and find that there's a flaw in this thinking. And this is actually correct. But until then, for me, this is what I believe to be the truth. In reality, this is what I believe to be the truth. Please let me know what you think. Let's talk, let's discuss about this. Let's grow the channel so that it reaches other people who are passionate about physics, who are passionate about STEM in general. So if after watching this video, I've managed to make you think a little deeper or plow a little deeper in terms of your thinking, I think I would have established my goal. However, I intend that this doesn't happen only at this instance. It happens throughout your entire life. You begin thinking differently, you begin plowing deeper and deeper and deeper. I'm going to be making more of these kinds of videos so that we equip each other, or so that we train each other to think in a way that's more deep and not that surface level kind of thinking. Now, if this is not actually this, but is this, what do you think happens to this guy? That's for another video. Thank you.